Hello. In our last video, we were trying to solve the problem of directing the robot to fill in all of the gaps in the walls with dark squares. And the particular problem that was driving us nuts about this is that there's no guarantee as to where those empty squares will be. It's possible that we might start up the world and discover that this brick wall is not here, and there is a brick wall over here where there wasn't in the previous world. So we want to be able to solve so that the robot fills in dark squares where there were no walls, regardless of where there are gaps in the walls in the robot's lovely new room here. And we'll assume that the dimensions of the room are fixed, so the room isn't going to get taller or shorter or anything, but whether there are gaps in the walls, that may vary. So that's the problem we're trying to solve. And what we learned is that we can ask Java to report to answer a question. And the questions that I can ask Java to report in this little robot world are: is the robot currently on a dark square? And is there a wall, is the space directly in front of the robot clear, or is there a wall? So we can ask, is the robot on dark? And this is how we write that, robot.onDark. And is the space in front clear? Robot.front is clear. So we can test these things, and the answer we get when we evaluate these expressions, these are expressions because they give us values, we get an answer from them. When we evaluate these expressions, our answer will be true or false. And I don't think we gave that a name, but there's an important word for that. These are called Boolean values. True and false values are called Booleans. I believe they're named after, I want to say George Boole, but I may have his first name wrong, who invented Boolean, a form of algebra that we call Boolean algebra, where he worked with true and false values. That's not important right now. Just remember, the word Boolean describes a type that could be true or false, a type of value that could be true or false, such as the values we get back from onDark and front is clear. What we don't know is how to use onDark and front is clear in our program, because the methods that we write in our programs consist only of statements, not expressions. Statements such as turn left or move, make light, make dark. And when we execute a statement, we execute it for its side effect. Executing turn left has the side effect that the robot has now turned left. And the only kind of statement we know so far are method calls, where we have a file name and dot, a method name, parentheses, and we call that method. For example, whatever file this is in, dot turn right would direct the robot to turn right by turning left 3 times. So we've got statements in our programs. We want to use these expressions somehow, and I think let's just plunge right in and see how to do this. So suppose that I have a program, and in that program I want the robot to move, and then after moving I want the robot to test if the front is clear. Test if the front is clear, and I don't know how to put that in my program yet. We're going to see in a moment. But depending on the answer, I might do one of 2 different things. If the answer is true, then I want to move, because the front is clear, it's safe for me to move maybe. If the answer is false, so there's 2 possible outcomes here. If the answer is false, then I've decided I want my robot to turn left in that scenario. And either way, I want to then continue on to the rest of my program, and let's say the next thing I'm going to do is make dark. So that's the program I'm trying to write. And this picture here, by the way, is called a flowchart. I don't think it's important that you know that term, but I'll write it out anyway. Flowchart. It's a diagram where I use arrows to direct the flow of a program. And I guess after making dark, the program will continue to whatever comes next. So we want to know, how do we write that? How do we put this test and then direct it to do move only when true, turn left when false, and then proceed from there? So how do you do that? Well, you use a new kind of statement. So we have a statement where we call a method, such as turn left, move, make dark, turn right, etc. And now we're going to have a new kind of statement, and that's called an if. And it reads pretty much like you'd want it to. You say if, well, actually let's write this program here. So we'll move, and presumably this is in some method somewhere. We'll move, and then we will test if the robot front is clear. If the robot's front is clear. And we write that exactly like this. And yes, there's an extra set of parentheses around here. You need these parentheses. Without the parentheses, you will get a parsing error. Your program won't compile. And an if consists of two parts. Well, three, I guess, because we have the test condition up here, and then we're going to have some statements, and there could be several statements in a block surrounded by braces, else some statements. And the idea is that these first statements are executed if the front is clear. The second group of statements is executed only if the front is not clear. In other words, when Java executes this if, it's going to first evaluate this expression, robot front is clear, and get a true or a false value. If that value is true, only these statements will execute, and if that value is false, only these statements in the else will execute. Either way, the program will then proceed to whatever's next, which maybe is make dark. So that's what an if looks like. In general, I'm going to have statements there. Specifically, I guess if I'm writing out the program to correspond to my flowchart on the right, I'm supposed to move if the front is clear, and turn left if the front is not clear. So if the front is clear upon moving, we'll move and then make dark. If the front is not clear after the move, we will turn left and then make dark. Why would we want to do this? I don't know, but it's a wonderful illustration of what it looks like to use an if. So now I want to actually go ahead and use an if in my program to solve this lovely problem. So let's bring up my program. Actually, I didn't really write any of the program yet, so now we can get started. So, complete the room. In this problem, my robot is in a situation like this, and I'm going to use top-down design. So I will start by realizing, well, completing a room really means completing 4 sides of a square. So I recognize that the main thing that this robot is going to do over and over is complete a side, and it's going to complete a side 4 times. So whenever we write a program, we want to ask ourselves, what are the main pieces of this program? What are the main tasks the robot has to complete? Well, it has to complete a side of the square. So we'll do that. Let's expand this. Okay, so, and you can see I've already defined some methods for us, like turn right and back up and so on. So I'm going to insert some methods in my complete room, which currently does nothing. And what I want it to do is, by the way, I should tell you that we're in a file now called room. So if I want to call a method within this file, I have to say room dot. So I'm going to say room dot complete one side, complete side. And there are 4 sides, 2, 3, 4, so we'll call complete side 4 times. Now I haven't written complete side, so that's the next task. Public static, that's that incantation we always write, and we don't know what it means yet, but we'll learn it soon enough. Public static void complete side. Complete side. How do I complete a side? Well, what does the robot have to do when it completes a side? Well, it has to complete... Actually, before we write the code, we should probably agree on what will be true before complete side is called, and what will be true afterward. So what's true before? Robot is at the beginning of a side. The side is to the robot's left. And I suppose we can say, we can define what a side is, that the side always consists of 5 squares, but let's keep it simple here. Afterward, what should be true? Well, the side should be complete. Side has been completed. What else is true afterwards? Where will the robot be? Well, the robot will probably be up here. So, robot has reached end of side. And which way should the robot be facing? So we could leave the robot facing in its original direction, but that means we would now need to turn before we could call complete side again. And when I wrote this program up here, I apparently assumed that complete side got the robot into a position where it was now safe to call complete side immediately afterwards. So not only should the robot reach the end, but robot is now, or next side is on robot's left, which means the robot has already turned. Okay, so let's write complete side. What do we have to do to complete the side? Well, we have to complete a wall. Complete wall, so I'm going to imagine that I define a method in my room file called complete wall. I'm programming optimistically. And how do I complete a wall? Well, we'll deal with that later. But I complete a wall how many times? 1, 2, 3, 4, 5. And remember this, the wall might already be complete, in which case this won't actually do any completing, but it will identify that the wall is already complete. And we said 5 times I need to complete a wall on each side, so here's 5 times. Now we have something worth thinking about is, actually, I think I'll leave this for the next video, and we'll start writing complete wall, which would be much more interesting, because then we'll start actually having to test whether the wall's already complete or not. But also in the next video, we can dissect whether complete the side really is complete wall 5 times, and I'll let you think about that, and then we'll fire up the next video in just a moment. I will see you there.